So now you guys understand what is momentum, right? And you also saw a few examples of momentum, right? Now based on this momentum, let's see what is the law which is defined. Okay, see now let's say you have a body. Okay, let's say you apply force to it. Alright, if you apply force to that particular body, it moves, correct? It moves. So if you have an object of mass m and it is moving with some certain velocity v, that means it has momentum in it, correct? So basically here the rate of change of momentum and force applied on the object, these two are proportional, correct? So we come across the law which says the rate of change of momentum is directly proportional to the force applied on the object, and the change in the momentum is in the same direction of the force. Okay, this is what we call as Newton's second law of motion. So first law was inertia, second law is this. Okay, now what does the actual statement say? Let's go through the statement. See, it says the rate of change of momentum is directly proportional to the force applied, correct? See, this means, so momentum is defined by P, or it's denoted by P, correct? P is equal to mv. So P is equal to mv. Now dp by dt, see when we say dp by dt, meaning for a very small amount of time dt. Okay, see, usually we take the time as t, correct? Now, whenever if the change is very small, like 0.1 second, something like this. If the change is very small, we call it as dt. Okay, you will understand why dt. In mathematics, you will learn why we call it as dt. Okay, so for a very small amount of time dt, very small change in momentum is happening. Let's call it as dp. Okay, so dp is the change in momentum, dt is the change in time. So rate of change of momentum becomes dp by dt. Okay, so now we have F proportional to dp by dt. Force and change in momentum are proportional, right? Now to remove the proportionality, we have to introduce a constant. So let's call it as k. So we have F is equal to k into dp by dt. Okay, now when we calculate it experimentally, k value is 1. Okay, in SI units, SI terms, when we take it, k value is 1. So we'll get this as F is equal to dp by dt. Okay, now what is p value? Mass into velocity, that's m into v. So substitute. We'll get this as F is equal to d by dt of m into v. Now mass. See, tell me, suppose let's say you kick a football. Okay, will the mass of the football change? No, right? Only the velocity changes. So we can say, or we can conclude, that mass of the object always remains the same, right? Irrespective of whether you kick the football or you just stop the football, irrespective of what you do, mass of the football remains the same. So in m into v, m is always the constant. So we'll get F is equal to m into dv by dt. Now if you remember last chapter, that is linear in last to last chapter, that is motion in one dimension. Now what was the rate of change of velocity? What was rate of change of velocity? That was acceleration. So dv by dt becomes a, correct? So if you substitute that, you get this as F is equal to m into a. Now this is nothing but your Newton's second law application. Okay, or what we say is we deduced force, or the formula for force, using mass and acceleration. Everywhere you would have seen this formula itself, right? So force is equal to product of mass and acceleration. F is equal to m into a. Okay, understood? See, in this case, force F is a vector, acceleration a is a vector, whereas mass is a scalar. Okay, so a is equal to F by m. correct? So whatever force we are applying to that particular mass, that gives you the acceleration of the body. Understood? Now let's come to the SI unit and dimensional formula. Alright, see in this case, force F is equal to m into A. M is kg, acceleration is meter per second square. Right? So if you apply that, you get kg meter per second square. So we call this as Newton. So force, SI unit of force is Newton. Understood? 1 Newton. So whenever we say that force applied on the object or force applied by the object on us, if it is 1 Newton, that means the mass of the body has to be 1 kg and it is moving with an acceleration of 1 meter per second square. Okay, so then you will get the force of 1 Newton. Alright, now coming to the dimensional formula, you have kg meter per second square. So m L T minus 2. Okay, now this is the dimensional formula for force. So force is nothing but Newton, SI unit is Newton. Okay, so we also represent force as the change in momentum. Okay, change in momentum. Or we also represent force in terms of change in velocity. Okay, all these things you will see in the coming video. Alright, so go through this video again. So learn what is Newton's second law of motion, how force is related to the change in momentum. Understood?